Hey math enthusiast, I'm here to help you out with the notes on angle relationships in circles. So let's get started. First theorem we've come across is very similar to the theorem from the previous section with inscribed angles. Alright, but now instead of two chords, it deals with a tangent and a chord. So in my picture, what I'm referring to is chord AB here, and the tangent, this line right here with point A on it being the point of tangency. All right, so in this case, it's referring to angle 1 and angle 2 that are formed here. So obviously those two angles are supplementary. All right, and in this theorem, what they're talking about is the relationship between this angle measure and this arc that it opens up to. Now, I already know that the measure of angle 1 plus the measure of angle 2 equals 180. If I could squeeze in this 180 here. And in addition to that, I know that these arcs, so for example, this arc here, ACB, and arc BA together are going to cover a total of 360. So based on that, I can already tell that these angles in here, 1 and 2, are going to be half the measure of the arcs that they open up to. All right, and that's exactly what they say here. It's half the measure of the intercepted arc. So let's see if we can apply this theorem. So for this first example, the one piece they do give me is this arc, which is 128. I got to figure out the measure of both angle 1 and angle 2. Now, I know 1 and 2 are going to add up to 180. So I really only need one of those angles to find the other. Now, as we just learned in our theorem, the measure of angle 2 is going to be half the measure of the intercepted arc, 128, which gives me 64 for angle 2. So as soon as I have that, I know these two are going to add up to 180. So now all I have to do is 180 minus that 64, which leaves me with 116 for angle 1. For the next problem, it's just the reverse. They give me the angle here formed by the tangent and the chord, and what I want to do is figure out the arc measures. Well, I know 1 and 2 together cover the whole circle, so they're going to equal 360 degrees. So let's just focus on finding 1 to start. Well, I know the relationship between that angle and the arc. All I have to do is double it, which gives me 234 for arc 1. And then, as I said, I know this covers 360 degrees between arc 1 and 2, so I'm going to take away the 234. And now for this arc, I'm going to be left with 126. For this next theorem, I'm now dealing with two chords that intersect inside my circle. So we can see chord BD and chord AC. All right, so as I said, they intersect in my circle, which forms a whole bunch of angles. Now, obviously, I know that we have some vertical angles on the left and the right, and the top and the bottom. So what this theorem relates to is those angle measures relating to the arc measures. All right, and essentially, it is the average of the the average of the arc measures. So in this case, what you would have to do to figure out the measure of angle 1 is you would have to add the measure of arc DC plus the measure of arc AB and then take half of that. All right, that's why I said average, which would give me the measure of angle 1. All right, and then for the measure of angle 2, now I'm just using different arc measures. Now I'm using AD and BC. So let's see if we can actually apply this theorem to a couple examples. So for this first example, I'm looking for the measure of angle 2 and the measure of angle 1. Well, it looks like these two are a linear pair. So as soon as I have 2 or 1, I can figure out the other angle. Well, let's just focus on angle 2 because it opens up to this arc on the one side, 115, and then obviously these are vertical angles in the middle, and the arc on the other side would be the 97. So this is where we're applying that theorem. So I'm looking for the measure of angle 2. So it's going to be equal to half the sum of the two arcs that it opens up to, which would be 115 and 97. So this is going to give me half the measure of 212, which is going to equal 106. Now, as soon as I get the measure of angle 2, as I said, I can solve for the measure of angle 1. Let's clean this up a little bit. So, as I said, angle 2 is 106. 1 and 2 together form a linear pair, so they're going to add up to 180. So all I'm doing is 180 minus that 106, which is going to leave me with 74 for angle 1. Now, the next problem is a little different because they give me the angle formed by the intersecting chords. I do have the one arc that it opens up to 41. I'm looking for the other arc. I'm also looking for the measure of angle 2. Now, same as the last example, I know that these two angles form a linear pair. So if I want the measure of angle 2, all I have to do is take out that 47, which is going to leave me with 133 for the measure of angle 2. All right, now I got to go back and figure out angle 1, or arc 1. So let's stick with our theorem. I know the measure of this angle, which I'm given, 47, is equal to half the sum of the arcs. Well, my two arcs would be 41 right here, plus this one. And let's just call that x for right now. So I'm going to fill in x right there. So now I just need to solve this theorem, solve this equation. First thing I want to do is get rid of this half right here. So I'm going to multiply this side by 2, and I'm going to multiply this side by 2. Half and 2 cancel, and now I have 94 equal to 41 plus x. Last thing I got to do is subtract that 41, which leaves me with 53. So this arc over on this side is 53. Stick to the theorem, the equation from the theorem, to solve these problems. For the next couple problems, now I have to go through and actually solve for x. So now I'm dealing with the chord and the tangent, which form this angle. This is my first theorem from this section. So they give me the one expression, 3x minus 1, to represent my angle, 5x plus 33 to represent my arc. Remember, these two expressions are not going to be equal. All right, so you have to remember what the relationship is between these two. All right, well, remember, if I take half of this arc measure, then it will be equal to the angle. Or instead, if I double this angle measure, then it will be equal to this arc measure. So let's go that route. It might be a little bit easier. So I'm going to double that 3x minus 1 and set it equal to the 5x plus 33. So we got 6x minus 2. Lastly, it looks like I end up with x is 35. Next example deals with the second theorem with the intersecting chords. So I'm given the one angle inside the circle, 38 degrees. This arc that it opens up to is the 10x minus 1, and this small arc on the other side is just going to be x. Stick to your equation. I know that the angle inside, 38, is equal to half the sum of the two arcs. So when I add up my two arcs, it's going to be 10x minus 1 plus my other arc, x. So first thing I want to do is get rid of this half, same way we did before, multiply both sides by 2. Remember, these two are going to cancel out now. I end up with 76 equals 11x minus 1. Then you have 77 equals 11x, and it looks like x equals 7. For this next theorem, I'm now dealing with an angle that is going to be outside of my circle. Whether that angle is formed by two tangents, as we can see in this example in the middle, whether it's formed by two secants, as we can see this example on the end, or whether it's formed by one secant and one tangent. So for that angle, whether it's measure of angle 1, measure of angle 2, or measure of angle 3, it's always going to be half the difference between the two arcs. So for the first example, it's going to be half the difference between arc BC and arc AC. And that's going to give me the measure of angle 1. And it's the same in these two other cases. So for this first example, I have angle 1 outside of my circle formed by these two secants. So the two arcs they give me are 92 and 43. So let's stick to the theorem that they gave me. I know that to solve for the measure of angle 1, it's going to be equal to half the difference between the two arcs. You're always going to start with the larger arc, the arc on the outside. So it's going to be 92 minus 43. In this case, I don't have to move anything around because I'm solving for the measure of angle 1 just on the left side of my equation. Then half 49 is going to give me 24.5 for the measure of angle 1. Now, for the next example, once again, I'm looking for the angle outside of my circle, angle 1, which is formed by these two tangents, which touch my circle only at one point. Now, the problem with this example is that they don't give me the inner arc or the outer arc. The only thing they start me off with is this 64, this inscribed angle. Well, if you remember earlier from the previous section, the inscribed angle opens up to the intercepted arc. To find that arc, all I have to do is take that 64 and double it. So I know that this arc right here is 128. Now I also know that this interior arc and this exterior arc are going to add up to 360. So if I want the outside arc, all I have to do is 360 minus that 128. So now I know this arc on the outside, right here, is going to be 232. Now you can get started on solving for the measure of angle 1. So now I know it's equal to half the difference between the larger arc, the arc on the outside, at 232, minus the inner arc, that 128. So it's going to be equal to half of 104, which gives me 52. Now, for the next example, you're looking for angle 2, which is on the outside, and this little arc right here, arc 1, we'll say. All right, so what they give me is 134 for this arc and 170 for this arc. Well, I almost have the entire circle at this point except for this piece. So the first thing I'm going to do is 360 minus those two pieces that they do give me. So they give me 170 and they give me 134, which gives me 56. So now I have the measure of arc 1. Use the arc symbol here. Say is 56. So now I'm focused on the measure of angle 2, which is formed by this tangent up top and this secant down here. Well, let's stick to our theorem. I know to find the measure of that outside angle, it's going to be half the difference between the larger outside arc, 134, and the smaller inside arc. So we end up with 39 for the measure of angle 2. The last couple examples get a little bit more complicated because the expressions they're giving me for my arc measures are a little bit more than just x. So I'm trying to solve for x for these. They do give me 54 degrees. It's an angle outside of the circle formed by a secant and a tangent. So I'm going to stick to the theorem that they told me earlier. The angle on the outside, the 54 degrees, is equal to half the difference between the outside arc, which is 13x, minus 6, minus the inside arc. Now it's this whole entire expression, so I'm going to keep it inside of these parentheses here, 5x plus 14. So first thing I want to do is actually get rid of this half. So I'm going to multiply this whole thing by 2, which is just going to cancel out this half. and let's multiply this by 2. So now I have 108 on the left-hand side. If I can draw my 0. Now, what's going to happen in here is that this negative is now going to distribute to both of these terms. So I can get rid of my outside parentheses. So I still have 13x minus 6, but then it's going to become negative or minus 5x minus 14. All right, so that's the one big difference right there. This sign is going to change. Now we want to clean up this right-hand side, which is going to give me 8x minus 20. So on the other side, I still have 108. Now I'm going to end up with 128 equals 8x. So lastly, x equals 16. Biggest thing for these problems is you have to remember to distribute this negative right here. All right, that's going to make all the difference. So for this final example, there's a lot going on in my picture. Several chords, secants, and I'm given a couple arcs, 30 here, 70 here, and then this angle on here, 81. So let's really just focus on filling in what I can in my picture right now. So the first thing I notice is the 81 right here, which means that this angle on the other side is also going to be 81. And then I also know that these two are going to form a linear pair, which means that angle on the left is going to be 99, and then where this x is also going to be 99. So let's see what they're actually asking for. The first thing they want is angle WVR, okay, which would be the same as angle WVT, which opens up to this arc right here, WST. So if I can get this arc, then I know I can solve for this inscribed angle. So let's try to focus on figuring out what that arc measure is. So I'm looking for this arc right here. Well, what I could also do is trace these two chords that help form this arc because they end at T and they end at W. And I also know that this arc is 30, and then where my chords intersect are both 99. Okay, well, we have a theorem for this. I know that the angle where the chords intersect is equal to half the sum of the two arcs, which would be 30 plus, let's call this one x. So I can use this equation to solve for this arc. So I'm going to double both sides, which gives me 198, which equals 30 plus x. And then I'm going to subtract that 30, which gives me 168. So now I know x, this whole arc in green, is 168. Now remember, what they were actually asking for is angle WVR. Okay, this is an inscribed angle. It opens up to this arc, so I know that angle measure is actually going to be half of 168, which is going to leave me with 84 for my final answer. So angle WVR is 84, and the next thing I'm looking for is an arc measure, arc TUW. So we'll go back to our picture and try to find TUW. So that's going to be this whole entire arc. Looks to be a major arc. Now, remember, when I did the last problem, I found this arc, TSW. And I found that to be 168 degrees. Well, at this point, I've traced the entire circle all the way around. So between the blue and the green arc, I've covered 360 degrees. Well, to figure out that blue arc, all I'm going to do is take out that 168, which leaves me with 192 for that arc. So my final answer down here is going to be 192.